Hello friends, today we'll discuss the next topic of high voltage engineering in the mechanism of breakdown in the liquids. We have earlier studied the electronic breakdown in the liquid electrics. Today we'll discuss the suspended solid particle mechanism. As we know that commercial liquid will always contain the impurities either in the fibrous or dispersed solid particle. The permittivity of these solids epsilon 1 will always be different from that of liquid epsilon 2. Normally, the permittivity of epsilon 1 is greater than the permittivity of the epsilon 2. Let us assume these particles to be spheres is of the radius small r. These particles get polarized in an electric field E, and the experience of force that is given by this expression. Here, epsilon 1 and epsilon 2 are the permittivity of the foreign particles and the liquid electrics. A force given equation increases as the permittivity of the foreign element, that is epsilon 1, increases. So this expression can be written in this form, and if the value of epsilon 1 increases towards infinity, then this term will get towards 0, and the force acting on the particle will be written as this one: F is equal to R cube E and multiplied by dE by dx. In a uniform electric field, the dE by dx tends towards 0, so that the force on the particle is 0 and the particle remains in the equilibrium. The permittivity of the is a property of every material which measures the opposition of offered against the formation of electric field. If the number of particles is sufficient to bridge the gap, the particle will give rise to a local field enhancement, and if the field exceeds the dielectric strength of liquid, there will be local breakdown will occur near the particle, and thus will result in the formation of gas bubble. Gas bubbles will have much less dielectric strength, and hence finally leads to a breakdown of the liquid. The movement of the particle under the influence of electric field is opposed by the viscous force posed by the liquid electric, and since the particles are moving in the region of high stress, diffusion must also be taken into account for the realistic study. We know that the viscous force is given by the Stokes relation, that is F is equal to 6 pi eta RV, where eta is the viscosity, R is the radius, V is the velocity of the particle, and this can be given by this relation because the electrical force should be equal to the viscous force. If you equate these two, so this will give the this relation V is equal to R square E divided by 6 pi eta dE by dx. Further, if the diffusion process is included in the process, the drift velocity due to the collision will be given by will begin by minus dn upon d by n dn upon dx, and this can be written as here, where d is equal to kt upon 6 pi nr is a relation known as a Stokes-Einstein relation. Here k is a Boltzmann constant and the T is the absolute temperature. At any instant of time, the particle should have one velocity. Therefore, V that we have calculated earlier should be equal to the diffusion velocity. We just equated both one, and this will give the this relation. Here we can write the dn upon n as a log of ln of n, and ed can be written as e square by 2. It is clear that the breakdown strength E depends upon the concentration of particle n, radius r, viscosity eta of the liquid, and temperature T of the liquid. So it has been found that liquid with solid impurities has lower dielectric strength as compared to its pure form. Hence, this will degrade the performance of liquid dielectrics. Thank you. We'll discuss the next thing in the next lecture.